Welcome to the Michigan Travel Show, a kaleidoscope of stories about the people, places, and events that shape our great state.
Hello everyone. Well, Aaron Morgan here, Michigan Travel. Today we're at the Rapid plus TCT Aero Defense Manufacturing. Well, not just a it's here down at Huntington Place, and then SME Adaptive Manufacturing Award Ceremony, but that's just one of the little things. All of the Expo Center here is all about 3D manufacturing. It is pretty cool what they are able to manufacture off of 3D stuff. I've been amazed walking around here, all the different, like they can make stuff like that. And they make it with some wire. It's all with 3D. It's pretty cool. Industrial print heads for filament extraction. Next year it's going to be in Boston. Like I said, some impressive numbers that come out of Massachusetts. But over there, A3D manufacturer. This, and they use material compatibility. This is MMP technology. This, they use a variety of metals. But what's interesting, this is all involved with the SAE Congress. And so they've got a variety of things here. And I just been checking it all out. See, Aero Defense Manufacturing over here. All the top ones up there. But they have a variety of things here. It's been pretty cool. All this stuff, I'm just like amazed. And I wasn't, but you know, this was not around when I worked at General Motors. There's a lot of new technology. And they make different, some of it is rubberized, some of it like it's plastic, it's metal. And they do it with 3D imaging. Like ceramic additive manufacturing. It's pretty cool, all the stuff they have here. Like there's some stuff. It is so advanced, and they put this stuff in car parts. You know, you name it, they use it for something. You know, like there's something that's, but here, like a ceramic, whatever it is, that's rubber. You know? Some of it's metal, some of it's glass. That's some of the stuff they use to make it. Like I said, I'm just amazed as I've been through here. Like I said, they got even some shoes, clothing they make with it. Pretty cool. Some scanners, they make helmets. Hello. So over here they got mold making. Like I said, it is so advanced, even I am amazed with it. And this is in conjunction with the SAE Congress down here at Huntington Place in downtown Detroit. So, as I'm observing everything, it's pretty cool. Well, they even got up in the front, where I'll go back by that, where they have some toys and stuff like that. So we'll just check out the aluminum powder. Like right here. That is all made out of a 3D printer, all out of wire. Very cool. 3D metal printing. Large metal delivered in weeks, not months. 3D. They say 8 times faster, trains in 1 week. Bring it in from Asia and take 2 or 3 months. Yep, pretty cool. I'm, like I said, pretty impressed wandering around here. It is pretty damn cool. And then this the TCT group, and they are one of the manufacturers. And like I said, thought leadership, mind share awareness, market intelligence, digital presence, networking opportunity, accelerate product deliver, global reach, Lenja, print magazine, digital podcast, webinars, AM, machine, social, global exhibition, global conferences. pretty cool. A lot of this came into play after I left General Motors, and like I said, TC, this is like I said here in Detroit. It was Birmingham, UK later. So all over the world here, but in 2026, and it says returning somewhere in Asia. Anyway, there it all is. It's a phenomenal robot here, and like I said, industry pioneer in wireless 3D scanning. Pretty cool. So over here we have a slingshot cars. Pretty cool. Pretty cool. Yeah. So it must have helped create this car. That's pretty cool. Like I said, they got all these products. It is pretty amazing. This 3D printing, unlimited strengths for imagination. Filament, 3D printing filament manufacturing. So over here we have Kasai manufacturing plastics. Yeah, I saw them with their big prod. We used to view those at General Motors in my day. 3D printing materials. So it's a lot of wire that does it. Pretty interesting. I love it. Very, very interesting. And pretty cool. Even make toys with it. Rubber toy here. Right there, plastic, rubber. Pretty cool. All those knickknacks. Pretty cool. So like I said, they make a variety of products. Even over there, they're printing, they make the bottles. That is pretty unique. Like I said, they makes one of those. This is amazing. I am impressed. Like I said, they used a metal filament or printing filament. That is pretty cool. They have in here. Pretty cool. Yeah, I'm impressed. Done with a filament, but sometimes it's nylon, sometimes it's metal, but it's done through 3D printing. So 3D, you must give them the design. Standard raisins, well, there is the reason they use it, the reason they use it to make the product, make the plastic, whatever they want to do. Wow, this is pretty cool. Use this 3D for a lot of medical stuff. Hip, total hip, so I should have aluminum toughened, zirconia, but then, like I said, they got stuff for teeth, skull. So they use all this stuff also for medical stuff. Ceramic 3D printing. This is just pretty cool. I was wondering how all this stuff was done here.
Hi, my name is Daniel. I'm Director for Medical Solutions at Litos. Litos is the world market leader for ceramic 3D printing equipment. So we're offering the machines, we're offering the material and all kind of solutions around. So I want to guide you through our machine here. This is our entry-level R&D machine, but all the machine working very similar than this one. So what we use is a liquid material. It's a suspension of ceramic particles in a photoresin. It comes in cartridges and it gets transferred into the vat. The vat is a transparent glass bottom, and we're then, similar to DLP resin printing, we are now projecting each layer from below on the material, and the build platform is then pulling out the part layer by layer from the bath. The difference to conventional DLP printers is, one, the accuracy that you can achieve with that kind of technology, and others, the material is very viscous. You need to rotate it after each layer beneath this plate to recoat and to replace the consumed material, because it would not by itself flow back otherwise. So after you take out the parts, after they've been printed, you'll clean them from excess material, and then you'll put them in a furnace for debinding and sintering. There you burn off all the resin, and then you end up with dense, pure ceramic parts. And if we're speaking about ceramics, we have all kinds of ceramics. So we have alumina, zirconia as classical engineering ceramics, as well as silicon nitride that you might know from aerospace and from more sophisticated applications, as well as aluminum nitride as material, for example, for heat exchangers for power electronics. You can see it here in the center.
Yeah, aerospace stuff, yeah.
What you also can see here, we can do multi-material applications, for example, combinations of porous and dense materials, or different colored materials, or even combinations of metals and ceramics.
Okay, right. So let's go over where your medical
Absolutely.
devices.
Yes, sure.
You know, because people can kind of really relate to that, and because you know now lots of us have some type of part is from teeth to hips or whatever. So explain some of what all this is.
Sure, I want to guide you from right to the left. So you see on the right side hydroxyapatite bone replacement implants.
Bone replacement.
So
Cool.
the idea is if you have a major defect in your bone, for example from a car accident, which will not close by itself, you can support the body by placing a hydroxyapatite implant, which hydroxyapatite is basically the mineral fraction of your own bones.
Oh.
And so it's very biocompatible, osteoconductive, and it helps to close even critical size bone defects.
So I see here for the spinal, is that what you'd put inside somebody if they needed a new, you know, let's say a piece of their vertebrae?
Exactly. So if you have spinal disc disease and your neurosurgeon makes the indication that you need to remove that because all other measures failed, then they need to place some cage as a distance in between of your spinal bodies so that you don't get smaller and that you don't get crooked somehow.
Right.
So besides some screws to fixate that, they will get you those cages, fill it with bone replacement material, and they will fuse those spinal bodies together.
Cool.
And eventually it will be one spinal body.
All right.
But you
What about let's say teeth here? Orthodontic brackets, dental crowns. What about those?
So dental restorations, crowns, veneers is something that 3D printing is especially good for, as this is all individual products. Every crown that you produce for a patient is individual. There's no one like the other.
Right.
Also, it has very, very fine features and it needs best aesthetics in order to replace a very natural smile. What you can do here is veneers down to 300 micrometers.
Oh, okay.
So you can do non-prep, minimal invasive or non-invasive tooth replacement. So we want to speak of that like the third dental revolution. It started with bleaching your teeth some years ago. Then the aligners came to make them all straight. And now they might have some chipped parts, some not perfect shape. Now with veneers you can compensate for that quite easily. And because they're so thin, you don't need to grind down the teeth beforehand, but you can just put it on top of your existing one without hurting them. That's why we speak of non-invasive or minimal invasive dentistry here.
Okay. And then what about the hip right here?
The idea of this is a special topology optimized patient-specific hip implant, especially for young patients that might need another replacement later on. So currently, if you get a hip replacement, it will probably live for 10, 20, maybe 30 years. But let's assume you need at the age of 20 get the hip replacement, and it's very likely that within your lifetime you need to replace it. Now imagine you have such a big hip implant that will then loosen over time, you need to replace, then there's a lot of bone already gone. So you want to go for a very small implant and very light one. So this one is really optimized on strength on one hand, but also little volume, little weight, good osseointegration on the other hand.
Well, I see, and then it's put into the hip there, into the bone, with like a porous type
Right.
material instead of like a solid piece of metal.
Exactly. So that the idea
So it's
is-
easier to take out, or it grows in, or what?
No, it should draw in perfectly and incorporate perfectly,
Ah,
so
okay.
that it's fixed within the bone, and it
Right.
doesn't need to cement it.
Okay.
That's the idea behind it.
Well, thank you for the info, and I'll take a little bit of your information. But
Sure.
yeah, this has been very interesting walking through here. I always heard about 3D this and that, but
You see, you do sports.
I do sports too. So how is that? What is that all about?
So if you play football or soccer, there's
Okay.
a very frequent meniscus injuries when you
Yeah,
torn
right.
the meniscus, and then there is a need for the surgeon to remove that torn part of the meniscus,
Right.
so you don't you don't have a pain
Right,
every
of course.
time you walk. So this tool goes into your knee, and it's actually a small cutting tool that allows for the removal. And I want to show you the part.
Okay, let's go over here and see what else it does. I mean, you've got a variety of other medical stuff here.
If you look here from the behind, you have one big hole, and then there is 3 smaller holes.
Right.
You can see on the top small hole there goes a glass fiber for shining light in the area so that the surgeon can see properly. And the 2 ones on the side, you rinse the area so that again all the debris is there. You can rinse away, and through the center channel, you're then suctioning out everything that you removed. And this, what you can see here, this is the sharp edges.
So they don't have to go into the knee. Just with that. That's
Exactly, they go into the knee with that, so it's also minimal invasive.
it. Right, you're not putting a hole in your knee.
Exactly.
I mean, other than a
And-
little hole.
A little hole, and this is a multi-feature tool that you can print in once, and that makes it much easier also to develop new innovative.
And you could get rid of that one, then do a new one each time, right?
Exactly. Yes.
Right.
Yes.
So what else do you have? I see you got a bone and
You can see here how very thin this minimal invasive veneers is. It looks like almost
like
nail.
nothing.
Yeah, you can see how thin this is, and this is something that is really hard to do with conventional manufacturing.
Right.
And it will be much more expensive. Even if somebody would give you the machine for free, the material costs would be more than the whole production costs in our case here.
so when are you going to be coming out with veneers?
So currently we are in the regulatory process with FDA approval. So this is currently
About
a bit
a year.
difficult to say how long it takes. You know.
The usual year.
Yes, it probably takes a while, but we're on a good track.
Yeah, I mean you're making all these other medical stuff. What is the long bone here?
So this is actually a case from a young girl. She broke her forearm at the age of about 11
Okay.
years, and sadly it did not heal properly.
Right.
So she had an angle in her bone,
Right.
and she then had some problems moving her joint, her wrist joint, and that of course was painful, and she could not actually use it properly for
Right.
more than 10 years. At the age of 21, then she changed her surgeon, and this surgeon was aware of a new possibility, actually 3D printing, and then he went to one of our customers who was producing this specific implant, and what you can see, you can produce very precise angles
I'm
here.
going to see that.
So
Yeah, you can make any angle you want. That's awesome.
Exactly, and that allows you for adjusting this and to make sure that this is growing properly together. And within several weeks, she was completely free of pain after more than 10 years of suffering, and then she actually got her full function back.
Yep. Well, now they had that put in as an adult. Because
Yes.
they waited until she was grown
Yeah, but
before,
that-
because you
because-
couldn't do that as a kid, or you'd have to take it back out.
You could have done that earlier, but her former surgeon just did not know about the
But
possibility.
then the bone doesn't grow the same as
This material will
expand.
will resorb and will be eventually replaced completely by your own native bone
Oh, it
tissue.
will. So it will turn into a real bone.
Exactly, that's the thing.
And it goes right through this right here. It'll go right through that material and
it
go
will
in.
go firstly in the pores. Your blood vessels will grow into.
Of course.
And then your osteogenetic cells will go into, and then
this will turn into a
fuse.
real bone.
Exactly.
That is amazing.
And that's especially for children. This is awesome.
Oh, for young people.
You saw that the
Yeah, with
cranial
the
implant,
cranium here.
Now think that there is people with a hydrocephalus, and they typically need to fix it with several tens of screws.
Oh, many surgeries,
Yes,
bone
and then
grafts.
after some years you need to take it out because it did not grow
Right,
with
with
it.
all
that's,
that, yeah.
That's a horrible situation. But if you have something that gets incorporated and replaced, that's a much better situation for the children.
I should have had some of that done with my hip the first time around. But it is what it is. I just had hip replacement. Well, the second
But
time
you're doing
around.
quite well, I need to say.
It's okay. It's not what it should be. But where are you based out of?
Our headquarters, and originally we are from Austria, from
Right.
Vienna, and we have a local office here in Troy, New York, near Albany.
Okay, yep, I know where that's at, yes.
And U.S. is actually our strongest market
Of course.
worldwide. Yes.
That's true of every industry.
And we can proudly say our biggest customer here produces several millions of medical devices.
Oh,
here.
of course.
So
Oh, yeah.
this is not for prototyping. This is actual
is for real.
serial production.
Right. Now, where are most people, where is it manufactured at? You got different places around the country?
Yes, sure. Like we have customers all over U.S.
I mean customers, but where are these machines here? Somebody buys one around here and then they can do the work right here.
Yeah.
It's not done in Austria, it's
No,
done
no.
here.
We produce the machines in Austria and the material and gets all shipped here to.
And then
US.
somebody can buy one of those machines,
Exactly.
and then they can make
And
all
they
these different
manufacture
parts.
themselves, right? We are
Pretty
the
cool.
supplier of the machines and the materials.
So you make the machinery, but the operation of it is done here in the U.S.
Exactly.
So it can make these parts and stuff
All
like that.
locally, sure.
Oh, that is
And
pretty
we
cool.
also have complete maintenance service here in U.S.
Right, of
we
course.
Also we do a lot of small developments here.
Right.
And we've got a very good support team here. So if you've got any questions, you can just go on the phone, ask them. They help you with getting started. And we got a lot of training programs because we can only be successful if our customers
Well,
are
of course.
successful.
And then you're making all these specialty parts. I mean, if you're doing medical stuff, you're busy all the time.
Yes,
With an
I
aging
can tell.
population, I'm one of them. So that people want new parts, and if you're able to do them on a 3D printer,
Absolutely.
that's phenomenal.
Yes.
At a much cheaper price. So that's awesome. Well, this has been very
Not only
interesting.
about the price, it's just things like that you cannot do conventionally without mesh with good osteo integration.
Right, yeah, you
this
got
is not this is not something that you can get otherwise.
Right, for sure. You got some great technology. I love it. This is awesome. Well, I got to take some of your brochures, and thank you very much for the interview.
You're very welcome.
Here's another overview of this whole place. There's Nikon, obviously, camera, but you use cameras to make all this stuff. And so all the different companies. This was pretty good stuff. Like I said, the medical was really cool. Like I said, to make these cars, they're using 3D printers. This is some pretty cool stuff. I just talk to him all the time because he gave us all the stuff that they do with medical. And athletes and general population wants to know about that all the time. We're going to hit one down here at the end, though. And what's interesting here, this is his Rapid plus TCT industry publications, media sponsors, 3D. So, like I said, this is the first time I've been to one of these. There's a car they use some 3D imaging on. It is amazing, some of the stuff they have. And right here, then they make some toys with it. Right here's like a train set only with logos and using some computerized technology to keep them all moving. And and then 10 design contest of some sort. I have no idea. Like I said, you can make some interesting toys and monsters right here. There it is, and it goes in and it makes it. There's one of the machines. So it uses that wire or nylon, and it goes in and makes all that. Bike they made out of it here. Not the motor, but everything else around it. And then over here, creativity, creativity, and they can make monsters. And right there's one monster. They have all kinds of toys in here they make. Industrial 3D printing. Wow, wait. It's pretty cool. I am impressed. Yeah. It's pretty cool. Yes. It's all here at Cobo, or here at Huntington Place. And like I said, up there, you see they'll have all the different types of wires or nylon that they make it with.
You need a bigger gauge.
Yeah, that is pretty cool.
You can print this entire building.
You can print everything. It is amazing. I'm impressed. I don't even understand all of it. I just only understand a little bit of it. The Discovery Zone, I've walked through there. They're getting ready. Everybody wants to go home after 2 or 3 days. Time to head home and get out of here, even though this runs till, I believe, 6 o'clock. I'll take a quick walk through here and see what all is left. Rico, that I believe they were a camera company. So here it was. This is to go in. Rapid TCT, Aero Defense. And this was the press center. So pretty cool. Impressed. Okay, well, this was the mobility seminar by the World Congress, and there it all is. But didn't get a chance to interview anybody in here, but it goes by quick.